What is going on, everybody? It's Mr. Gus, and I'm in the physics conference room, and today we are dealing with parallel circuits. So simple parallel circuits, I've got a circuit over here with a battery, and then 3 resistors that are just in parallel. And we'll talk about the differences between series and parallel and how to solve this. Now, like always when we're practicing our circuits, I want to find the equivalent resistance, current, and voltage at each of these locations. So each resistor, and then total in the circuit itself. Now, let's cover a couple things first. We know that in parallel circuits, when I add a parallel resistor or a resistor in parallel, when I add a new branch, I decrease the overall resistance. Why? I do so because I allow there to be another path for current to flow. Our loop rule states that for every loop of wire back to the battery, the voltage consumed is equal to the voltage supplied by the battery. Net voltage is 0. The battery supplies a positive voltage. Each resistor or each loop would be consuming that voltage, assuming there's one battery. Okay, so this is going to use 6 volts. This is going to use 6 volts. This is going to use 6 volts because we have it always in a loop back to the battery. That is our loop rule for voltage. The other rule we have is that we have junction rule. The junction rule is a current rule. And what that means is that at each junction of wire, where junctions are like where roads meet or where train tracks meet or where wires meet. So when I have these junctions here, any current that enters this junction is going to be equal to any current that leaves that junction. So the total current in equals the total current out. This is based on chemistry's conservation of mass, the conservation of charge we call it in physics. This junction rule must be held true. Any current in equals current out, which means that the total current must be the sum of currents going through each of those branches. Understanding the loop rule and the junction rule is always key to understanding how to solve these problems, okay? Let's go ahead and see what we have. I know the battery has 6 volts. That's my equivalent resistance. We also know that we're in parallel, and I see 1, 2, 3 loops. Each of those loops have 1 resistor in them. Therefore, each loop is going to be supplied with 6 volts to it. So resistor 3 gets 6 volts, this gets 6 volts, and that gets 6 volts. It's kind of the beauty of the parallel circuit. When we're in series, every resistor in series has the same current. When we're in parallel, every resistor has the same voltage, assuming there's 1 resistor in each parallel branch. Now, let's go ahead and look at the current. Well, guys, I'm given my resistance. I found my voltage because we're in a simple parallel circuit. Let's go ahead and use Ohm's law to find the current. I like to do this at the top. I like to say, hey, this is how I find, there's my equation right across the top of this data table here. So 6 over 4. Let's just go ahead and make sure we do these right. 6 over 4, when I do that, come on, 1.5. You get 1.5 amps there. I can do this in my head. 6 volts over 6 ohms, I get 1.0 amps right there. 6 volts over 12, I get 0.5 amps right here. So far, so good. Now, I know that at each junction, current in equals current out. The current that enters here is the current that goes to this branch, and this branch. Because of that, I should take this current plus this current plus this current, and that should be the total current. So I'm going to get 0.5, 1.5. That's 3.0 amps is my total current. I can then use Ohm's law and find my total resistance. Let's do that. This over this. My total resistance is going to end up being 2 ohms is the total resistance. Now, the crazy part about this, like we said before, every time I add a parallel branch to a circuit, I should decrease the overall resistance. So much so that the overall resistance is less than even the smallest of the resistors. So you can see that up here. Now, there's another way we can check this number. On your equation sheet, there's an equation written like this. 1 over Req parallel is equal to the sum of 1 over R1. What this means is that any resistor in parallel, I should be able to add the inverses of those resistors, and it will be equal to the equivalent resistances inverse. Let's check. So let's go 1 over Req, which is total, is equal to R1 1 over 4 ohms plus 1 over 6 ohms plus 1 over 12 ohms. Now, I certainly can't do this in my head, but we can, do it here. The inverse of 4 plus the inverse of 6 plus the inverse of 12. Now, I get my answer to be 0.5. That's not the answer. Remember, 1 over the equivalent resistance equals 0.5. That's not the answer. I need the inverse of that. Well, what's the inverse of 0.5? Let's just double check. It ends up being 2, which is what I solved for using Ohm's law. This is a quick trick to test my answer. I use Ohm's law this way, I get 2. I use my equivalent resistance this way, I get 2. We can use either method that we want to find the equivalent resistance, either Ohm's law if we have current and voltage. If we don't, we have all resistors, we can go ahead and add them in parallel, and then boom, throw them right there. Now, I've solved for current, I know my resistances, I know my voltage. This is how a parallel circuit works, and this is how we can use loop rule and junction rule to figure out the answers to our questions here. All right? If you got questions, drop in the comments, send me an email, ask me in class. Until next time, see ya.